Okay, ladies and gentlemen, here we go. Today, we're going over circuit breakers, all right? So, it's going to be real basic, but by the time we get done, you should pretty much understand how they work and what's going on. So, I totally jacked a image off of YouTube, and I will give credit from the guy I stole it from. This is a fantastic picture of the inside of a breaker. Now we're going to take one apart here shortly, and we're going to go through it ourselves. But let me get my red crayon out here, and let me kind of give you an idea of what the heck is going on here. So this is your breaker, and there's a little clip in your breaker. Let me do this. Let me come to there we go. Okay, that little clip I was pointing to is this little metal clip in here. You can see it. Okay, we're going to go right back to it, and this is the beginning. This is where the electricity or your power enters your breaker. It starts here because this clips in your panel right there. There's your panel, and that's all goofy, huh? Let's see here. There we go. These clip in, that little metal clip right there clips right on there, like so. Okay. So metal clip clips on the bus bar. Very simple. So that's where your electricity comes in. Okay, it comes in here. You need to remember this when you go back to our little picture. It goes through the electrical mechanism in here. Starts from the bus bar, goes to the clip, goes through here, and then your wire. If I had this strip, comes out. Your wire goes underneath the screw right here, okay? Just like so. Of course, probably need to loosen that some. There we go. So, again, power comes in here, leaves here, and this goes out to like a receptacle or a switch or something, you know. So again, power comes in here, goes through here, comes out here on this screw where you hook your wire to. And that'll run to a receptacle, a light, a plug, a load, microwave, refrigerator, anything. So now let's go back to a picture of our circuit breaker. All righty. Okay, now that little clip that I mentioned about 20 times is this little clip right here. This is a part that clips on the bus bar. Okay, so in other words, your bus bar would be like, it would come through here like so. I'm going to draw like a little bus bar. Wow, that's a nice straight line. It did good there. This part will come up, it'll clip in here, just like we saw. It'll come out like so, all right? So that would be your bus bar clipping in your breaker. So this is your bus bar right here. This is your bus. This is your power for your panel, okay? Comes into your breaker, and let's follow it. It goes through here. Now look what we have here. Right here, where it says it right here, contacts. There's a little set of contacts. You can see this is one side of the contact right here. This is one side of the contact right here. This part opens and closes just like a switch. So then, since they're closed right now, your electricity is going to go, your power is going to go through here, going to go up to here, and go on this wire, All right. Follow it around. It's going to go to here and go to here. It's going to run up to here. I'll follow this to here. And look, this is where the screw was, where I was putting the wire. So if you had a wire, if I change my color, if you had a wire, your wire would go under this screw, okay? This would be your wire sticking in here. All right? That's a bad wire. But anyway, you get the idea. I was going to see if I could erase that last part of it. But that wire goes under this screw. So you can see from the bus, comes in, goes through here. That's the contacts. That's important. This is what makes and breaks whether you have power or not. It turns it off and on. And then you have the little handle right here that operates this lever, so you can do it manually. If you flip this lever, you'll see it. It will open and close this. Now there's something else that can open and close it. There's a bimetallic spring in here that starts to bend the hotter it gets. So if it starts getting hot, it will bend and it will pull this, it'll pull this open right here, which you can see is tied to the switch. And these springs will make it pop open once it gets to a certain point. Or if you get a lot of electricity at once, just flows through there, it will magnetize this. It'll suck this little piece of metal right here. It'll suck it in right to here. And when it does that, it will cause this thing to trip and open these contacts. So there's three ways that these contacts can open. One, you can operate the lever, that'll open it. Two, if you're drawing too much current, like you have a microwave, a toaster, a refrigerator, a hair dryer, you got them all going at the same time, this little piece of metal right in here is going to heat up and it's going to bend. And when it starts bending, it's going to come over this way and it's going to operate this mechanical mechanism and it's going to open these contacts. Now the other way is if you get a direct short, you have tremendous current flowing through there at once. It's going to magnetize this and it's going to suck this in and it's going to operate this mechanism and open it. So that's the three ways: a lever, manually, too much current, it's going to do it with heat, or instantaneously, exponential amount of current is going to magnetize that and close it. So this is a thermal magnetic, oh, there it is, thermal magnetic strip. So there it's all, this is a really great drawing. It just shows you everything. This guy did a good job. So let me go down here so I can give credit where credit's due. Clear drawings, shut that off. This guy right here, Warp Perception, he's got some good videos. So this is where I stole this from. So now I've given credit, so I don't feel so bad I stole it from him. But man, he did a good job. So your lever, your contacts, where you hook your wire, your terminal, okay? Actuator mechanism, anyway. Actuator, I can't even say that word. Thermomagnetic strip. The most important part of this, he didn't list this. To tell you the truth, let me get my crayon back. Most breakers are going to malfunction because either these little plastic pins, like this little plastic pin here, if it gets bumped, it can break. There's a little plastic pin in here, it can break these pieces. A little pin in here. If this gets shoved right here or hit hard, you can break these little plastic pieces where everything pivots and your breaker will not operate correctly. The other place where breakers go bad, 99% of the time, it'll either be this right here. It got busted. You know, one of these little plastic pivot points got busted. Or this is a piece of spring steel right here, all right? So it will squeeze down on that bus bar that hooks up in here, and it squeezes it tight. If this gets hot and loses its springiness, or gets hot and gets all corroded and kind of burned up, this will not make a good connection, okay? So this is where things go bad right here. They go usually bad right here, or a broken piece on the breaker. I mean, it's doubtful. These contacts are usually pretty good. Theoretically, these contacts could get burned up. They could stick together for some reason, even though they're designed not to, or they could get so much corrosion or carbon on them that they don't, you know, make a good connection. But other than that, these things are pretty good. Don't lose the screws out of these, because you're not going to go down the hardware store, get another screw. They're a special screw. And you'd have to rob one out of another breaker. Now, you end up with a bad breaker no matter how you look at it. But yeah, I guess you can strip these out. That's rare, but that can occasionally happen. So anyway, so here's the, I'm going to put a link to this video so you guys can look it up. But if you're actually just finding this on YouTube, here's the guy right here. If you want to watch a good video, like if you're not in my class right now and you're just kind of on YouTube surfing around, go to this guy right here. You know, I was very surprised. He did a very good job on this. So anyway, moving on, let's go take a breaker apart ourselves and take a look in there where we can see how all this stuff works. So remember, contacts, lever, actuator, mechanism, thermomagnetic strip, and terminal. Yeah, all right. So let's go to here. Whoop. Okay. Square D breaker, just like you've got in the video. This is probably one of the most common breakers nowadays. I mean, I got some Zinscos out there, but thank goodness those aren't around anymore. Those things are always going bad. They're super expensive now. Okay, so gentlemen, there's only two things you need to know when you get in a breaker. That's your amperage rating, where it's going to trip, how much current it will take before it shuts off, and you have to make sure it's the right voltage. In other words, you can't put a 120 volt breaker in a 480 or 208 panel. I mean, it's not rated for it. But so you got to watch out for your amperage and your voltage. They have an AIC rating. That's, I mean, if you're an electrical engineer, you're doing some big commercial stuff or industrial, then you need to know that, but we're not going to get into that in this class. So make sure the amperage rating, the number on here, has to match your wire. So this breaker protects your wire and all your devices. So number 12 wire is good for 20 amps, 14 for 15. So you could only put 14 or larger on here. Now you can put this on number 12. You can put it on number 8. You can put it on bigger wire, but you're gonna not use the wire to its full potential. In fact, you could put it on number 8, and you could run out, let's say, 100 yards, and then have all your little plugs and switches and stuff on 14, but then you would have to put it on a 15 amp breaker, not a 40. Anyway, so I'm rambling. Let's take this thing apart. So let's get rid of these rivets. when they were wanting to spin on me. Yeah, that one's starting to spin. So I'll get them sideways. We'll get all those rivets off of there. Looks like that might pop out now. Hey, we got that one out. All righty. So there we go. Okay. Now you can see 3 rivets hold it together. Now, let me open this so the pieces stay in. So I need this side down. There we go. Just like on the picture. Very nice. There we are. Okay. So, as you can see, there's our little contacts right there. Like on the picture. Whoop, let me turn this way. There are little contacts. Our power is going to come in here, go through here, from that wire, through here, through that bimetal switch. Whoop, on that bimetal switch up here, and then our wire is going to hook on here and go out to our load. So let's look at some of this stuff. You can see, I'm going to turn this, right now it's on. We can use our little meter. And we'll check our meter and make sure it's working. And it is working. So there we have a complete circuit, and there we don't. Now it's open. So let's go from right here. This is where the bus bar would clip on, and then this is where your wires would go. Whoops, this is where your wires would go. And you can see, making a complete circuit. So right now, this switch is closed. So now, I got my leads all tangled up. Let's open this thing up without it flying apart. And you can see our little contact opened up right there. It is not closed anymore. And to prove it to you, right there, see? Closed, open, we got nothing. Yeah, it works better without the light. So, I'll close it again. You can see how that operates. Closed, open, just like a switch. Now, the deal is with a breaker is you can operate it manually, but as we talked about on the picture, that there's this little bimetal spring in here, and when the current exceeds 15 amps, this thing will heat up and make this thing trip, or if it's a lot fast, it will turn it into a little magnet and make it trip. It'll just bam. So let's take this thing apart and kind of take a look at it. So here's our switch. Well, there's a little spring part I was telling you. This little part here is a little spring steel, and when this gets hot, this will spread open, and it will not grip your bus bar, and that's sometimes where your breakers will go bad. Or they can get burned up in here. And once they get loose and they lose their springiness, once they get hot, they'll lose their springiness, and then they won't grip, and then they'll get all corroded and burned up in here, and it'll mess your bus bar up. So this is probably, if you ask me, this and broken handles, the #1 cause of breakers going bad. Usually all this other stuff is fine. This little clip here, now you can squeeze this back together with some pliers. You know, you can't take your breaker, well, you could take your breaker apart, but you don't want to take a breaker apart because you avoid your UL listing. But you can sometimes, if you're in an emergency, you can squeeze file in here, squeeze it back together, okay, and then put it back in. But that's just temporary. That's just to get stuff working in an emergency. Once this happens, you need to shut your panel down, clean that bus bar, and get a new breaker. Or get a new breaker and move it to a new spot in your panel on a bus bar that's good. But so contacts, and then these are your other contacts right here. So these two contacts are going to make and break right like so with this lever. We'll pull this guy out. This is a nice little breaker. This one got all kinds of grease in there and everything. They put a little grease in there. That's cool. There's your spring that helps make that thing trip once it, goes over the, they got another little spring right there. Okay, so this is basically where the freaking magic happens. These are little two pieces. You can see there's one right here and one right here. You see how this metal is made? This is just kind of this regular galvanized metal, but this little bimetallic piece of metal on here is made to warp when it gets hot, all right? If you look really close, I don't know if you can see it or not. Let me see if you can. Well, you can't see it on the screen, but it has little 15s on there. I had a 20 open earlier. It had little 20s on there. So that's basically telling you that this is made for a 15 amp breaker, all right? So the 20s were 20. And where your wire goes through here. So your current actually flows through this magnetic spring, causing it to heat up or cool down, or heat up and bend if it takes too much. And then if you get too much, you got another little bimetallic spring on this thing down on the bottom, and it acts like a magnet and freaking sucks it in and makes everything trip. So there you are. Basically, you got your lever, so you can operate it manually. You got your bimetallic spring, which is going to operate it thermally. And then you have your little piece that turns into a magnet, which operates it magnetically. So that's for if you get like 1,000 amps going at once, it's going to shut it off right away. But like this 15 amp breaker, if you're drawing, 15 amps, you start getting above 15 amps, it's going to heat up and shut off. A lot of these are rated, they'll trip below 15, some over. You know how everything is made in China nowadays. But it's supposed to trip around 15 amps. It's supposed to trip under 15 amps. Like 17, I think, what's this, 17%? Anyway. There's an actual percent they're supposed to trip out, but my experience is it's all over. They're all around. Some trip over, some trip under. just because things aren't made good anymore. But anyway, I doubt they calibrate and test every one of these breakers when they make them. They might, but who knows. So your terminal, where your wire goes, your clips on the bus bar. Again, to reiterate, where these breakers, most of the time, the reason they don't work is because this loses its springiness and it's not clamped on the breaker, or it gets carbon or corrosion in here. Your contacts could possibly, these two contacts could possibly go bad, stick together, or they could get so corroded that they don't make good contact. Or these little pivot pieces will bust right here in this pivot, and then, you know, if this gets hit. Anyway, gentlemen, I don't know what more to show you about the breaker. Watch that video. There's no sense in me reinventing the wheel. Watch that video, and he shows you, he actually hooks one up that's open and causes stuff to trip. So I could do that for you too, but he's got all these slow motion. He does a real good job. There's no sense redoing it. All right, gentlemen, I don't want to make this video too long. I don't know how long it is now. So adios. We'll see you tomorrow. Let me get to my, or as one of my students say, deuces.